Hello, grade 8. This is Mrs. Lopez. We are in our last lesson of Module 1 about scientific notation. We are in Lesson 10 and we are working on operations with numbers in scientific notation. Lesson 10 is just a bunch of problems for your review of how do we work with scientific notation. Do I add, do I subtract, do I multiply, do I divide, and how I do it. So let's start with example 1. The world population is about 7 billion. There are 4 and 6 tenths times 10 to the 7th ants for every human on the planet. About how many ants are there in the world? Okay, so I know from this problem that there are 4 and 6 tenths times 10 to the 7 ants for every human. So for one person, there is so many. And I also know that there are 7 billion people in the world. So what operation am I going to do to find out the total amount of ants in the world? I'm going to do division because this is for one person and that's how many people I have. So I'm going to multiply 4 and 6 tenths times 10 to the 7th by 7 billion. But first I need to write 7 billion in scientific notation because that's what my job is this time, is to know how to multiply numbers in scientific notation, not in standard form. So 7 billion I can rewrite as 7 times 10 to the 9th because billion has 9 zeros, right? 7 times 10 to the 9th. So I'm multiplying 4 and 6 tenths times 10 to the 7th times 7 times 10 to the 9th. Couple things that I see here. I see that it's only multiplication, so I can use my commutative property to switch numbers around. I can do 4 and 6 tenths times 7, and I can do 10 to the 7th times 10 to the 9th. And I can do them separately. I can put them in parentheses if it'll be easier. So now I can use my calculator, and that's what I'm going to do to multiply 4 and 6 tenths times 7. 4 and 6 tenths I'm multiplying by 7, and that is 32 and 2 tenths. So that's what I'm writing, 32 and 2 tenths times. Now I have 10 to the 7th times 10 to the 9th. I'm multiplying numbers with the same base and different exponents. So what is that rule that I'm following? I'm adding the exponents, and I will get 10 to the power of 7 plus 9. Okay. Now I'm thinking, well, 32.2, that's all good, times 10 to the 16th, that's all good, but is this number written in scientific notation? No, because 32 is greater than 10. I'm going to take that 32.2 and I'm going to change it in scientific notation. I'm going to decompose it to make it into scientific notation. I don't even have to worry right now about 10 to the 16th. I'm looking at 32.2. Where should I move my decimal? My decimal should be in between 3 and 2. So I will have 3.22 times 10. To what power do I need to multiply 10 to move my decimal back? It's to the first power. So now I have changed this number into scientific notation, 3 and 22 hundredths times 10 to the first. Now I can add on times 10 to the 16th. Now I see that I have 10 to the first and I have 10 to the 16th. I can combine them together and I will have 3 and 22 hundredths times 10 to the 17th. And that is going to be my answer. I have the number written in scientific notation multiplied by 10 to the power of 17. Sorry about that. The light just went off. Example 2. A certain social media company processes about 990 billion likes per year. If the company has approximately 8 and 9 tenths times 10 to the 8th users of the social media, about how many likes is each user responsible for per year? Write your answer in scientific and standard form notation. So, couple things here. We have the total likes per year, and we have how many users there are. My job is to find out how much one of them is responsible for. So I'm actually going to divide the likes by the number of users to get likes per one user. So I have 990 billion that I have to write in scientific notation first. So I'm going to write that 990 billion will have 9 zeros. And now I see, how can I rewrite this number in scientific notation? My decimal has to be in between 9 and 9. Now, how many decimal places do I have? I have 9, 10, 11 places. So it's times 10 to the 11th. And I have to divide that number, 9 and 9 tenths times 10 to the 11th. I'm dividing by 8 and 9 tenths times 10 to the 8th. Now I take each part separately. I have 9 and 9 tenths over 8 and 9 tenths. This is not a subtraction problem. This is a division problem. So I'm going to divide 9 and 9 tenths by 8 and 9 tenths. And I will get this number right here. So I have approximately, I can say 1 and 11 hundredths. Maybe even 3 decimal places. 1 and 112 thousandths. 1 and 112 thousandths approximately, right? Times 10. And now looking at this part. This is a division problem where I'm dividing the same base with different exponents. What do I do with the exponents when it's a division problem? I subtract them. I have 11 minus 8. So my answer is going to be 1.112 times 10 to the third. That's my answer written in scientific notation. But they also ask us to give the answer in scientific and standard form. So I need to change my number into standard form. So I have 1 and 112 thousandths. And now since I'm multiplying by 10 to the third power, I'm moving my decimal. I'm multiplying by 10, by 100, by thousands, 3 times to the right. So my answer is 1,112. So that means that each user is responsible for 1,112 likes per year. Okay? 2 answers here. Okay, exercise 1. The speed of light is 300 million meters per second. The sun is approximately 1 and 5/10 times 10 to the 11th meters from the earth. How many seconds does it take for the sunlight to reach the earth? Okay, so here I have the distance from the sun and I have the speed of that light. If I divide the distance by the speed, I will find the time. So I'm going to divide the distance by the speed to find time. This is an important formula that many of you should know, but if you don't know, it's very important for you to learn it. Okay, so my distance is 1 and 5/10 times 10 to the 11th meters, and I'm dividing it by 3 times 10 to the 8th. I have 8 zeros after the 3. So 3 times 10 to the 8th. All right. So now I'm dividing 1 and 5/10 by 3. I'm taking my calculator and I'm dividing 1 and 5/10 by 3. I get 5/10. Okay, so I write 5/10 times 10, and I'm subtracting exponents. 11 minus 8 is 3. Is this number written in scientific notation? No, because 5/10 is less than 1. So I'm taking this number and I'm decomposing it into, I'm writing it in scientific notation. My decimal has to be after 5 because that's the only way I can have my number be between 1 and 10. So I have 5. Now, where do I need to go? And by what power of 10 do I need to multiply to go back? That will be 10 to the negative first. And then I have times 10 to the third that I'm just writing down. So now I have 5 times 10 to the negative first times 10 to the third. I'm multiplying two numbers with the same base, different exponents, so I'm adding exponents. I have 5 times 10, negative 1 plus 3, and that is 5 times 10 to the second. Because power of 10 is so small, I can actually write it down in standard form. I'm moving my decimal over to the right twice. I'm multiplying by 100, and I get 500. So it takes 500 seconds for the sunlight to reach the earth. Okay? All right, so we worked on multiplication, we worked on division, and these are things that we already talked about. We already know what it is. So now let's talk about something else. I'm hoping it's going to be either addition or subtraction. Well, let's see. Exercise 2. The mass of the moon is about 7 and 3/10 times 10 to the 22nd kilograms. It would take approximately 26 million moons to equal the mass of the sun. Determine the mass of the sun. This is actually, again, another multiplication problem. We have the mass of the moon, of one moon, and we have how many moons there are. So I need to multiply the two numbers together to find the mass of the sun, because that equals to 26 million moons. Okay, so I'm doing 7 and 3/10 times 10 to the 22nd, and I'm multiplying it by this number written in scientific notation, which is 2 and 6/10 times 10. After the decimal, I have 7 numbers, so 2 and 6/10 times 10 to the 7th. Again, I can switch the numbers around here and multiply 7 and 3/10 by 2 and 6/10. And then I can multiply 10 to the 22nd by 10 to the 7th. Okay, so I'm taking my calculator and I'm multiplying 7 and 3/10 by 2 and 6/10, and you will get 18 and 98 hundredths. 18 and 98 hundredths times 10. Now we are looking at what I'm doing with the exponents. I'm multiplying the bases, same bases with different exponents. Since it's multiplication, I'm adding the exponents. 22 plus 7. So I get 18 and 96 hundredths times 10 to the 29th. Is this number written in scientific notation? No. I'm changing 18 and 96 hundredths into scientific notation. 1 and 896 thousandths times 10. I need to move my decimal back so to the right, so it will be first power. And then times 10 to the 29th. My answer now is going to be 1 and 896 thousandths times 10 to the 30th, because I have to combine the exponents here. That is the mass of the sun. It's in kilograms, and that's the mass of the sun. Pretty big number. Okay. All right. Let's look at example 3. In 2010, Americans generated 2 and 5 tenths times 10 to the 8th tons of garbage. There are about 2,000 landfills in the United States. Assuming that each landfill is the same size and that trash is divided equally among them, determine how many tons of garbage were sent to each landfill in 2010. Keyword here is divided, right? All the trash is divided between 2,000 landfills. So we are dividing all the trash, 2 and 5 tenths times 10 to the 8th, by 2,000 is 2 times 10 to the 3rd. Okay? So we are taking the calculator again and we are dividing 2 and 5 tenths by 2 and we get 1 and 25 hundredths. 1 and 25 hundredths times 10. This is a division problem. One number is standing on top of the other one. We are subtracting exponents. We are not multiplying them. We are subtracting. 8 minus 3. So I get 1 and 25 hundredths times 10 to the 5th. That's how many tons of garbage is distributed among all the landfills. Okay. Exercise 3. The mass of the Earth is 5 and 9 tenths times 10 to the 24th kilograms. The mass of Venus is this huge number. Compared to Venus, how much greater is Earth's mass than Venus's mass? So now the key word is how much greater. We actually came to a subtraction problem here. We are going to subtract Earth's mass and Venus's mass. First, I need to make sure that my number is written in scientific notation because this is ridiculous to do using standard form. So I have 5 and 9 tenths times 10 to the 24th minus, and we are going to subtract the Venus's mass, but I need to see how many digits there are going to be after the decimal that is in between 4 and 9, right? So I will count 3, 6, 9, 12, 15, 18, 21, 24 times 10 to the 24th. Okay, so now here's the place where I cannot move things around just because I don't have all the multiplication problems. I have a subtraction problem here. So I cannot subtract the powers. I cannot subtract these numbers. What I want to do, I want to use a distributive property. I see that both numbers have a factor of 10 times to the 24th power. So I can take that and put it outside the parenthesis. And I will put inside 5 and 9 tenths minus 4 and 9 tenths. And that is multiplied by 10 to the 24th. Now, if I will have to do the opposite, I would multiply 10 to the 24th by this number and by this number, and I will get exactly the same. So now I can subtract 5 and 9 tenths and 4 and 9 tenths. That is 1. And then I have times 10 to the 24th. That is all. So the mass of the Earth is 1 times 10 to the 24th kilograms greater than the Venus's mass. Okay. Exercise 4. Using the information in exercise 3, find the combined mass of the Earth and Venus. Combined mass is when we have to add. This is an addition problem. So I will take these two numbers, 5 and 9 tenths times 10 to the 24th, and 4 and 9 tenths times 10 to the 24th, and I will add them together. So 5 and 9 tenths times 10 to the 24th, and I'm adding 4 and 9 tenths times 10 to the 24th. Addition problems follow the same rule as subtraction. I cannot change numbers around. I cannot add or divide or do anything here. So what I can do is to see that both numbers, both terms here have 10 to the 24th as a factor. So I'm going to take it outside. I have 5 and 9 tenths plus 4 and 9 tenths, and that the whole thing is multiplied by 10 to the 24th. So now I can add those exponents. No, I can add these two numbers together. 5 and 9 tenths and 4 and 9 tenths will be 10 and 8 tenths times 10 to the 24th. But this number is not written in scientific notation because 10 and 8 tenths is greater than 10. I will have to change it into scientific notation first. So where do I need to put my decimal? In between 1 and 0, right? 1 and 8 hundredths times 10. And to bring it back, I need to move it once to the right. So it's going to be 10 to the first power. And I'm multiplying it by 10 to the 24th. And that's how I get 1 and 8 hundredths times 10 to the 25th power. Because here I'm combining exponents because I'm multiplying I'm multiplying 10 to the power. Okay, so that'll be kilograms. That's how much both of them weigh together. Both of the planets weigh together. Okay, exercise 5. The combined mass of the Moon, Earth, and Pluto is 5 and 986 times 10 to the 24th. How many combined Moon, Earth, and Pluto masses are needed to equal the mass of the Sun? We are looking at the answer to exercise 2. So how many of these can fit into these? That is a division problem. We are looking how many can fit into. So that is going to be division. I'm going to divide the mass of the Sun by this number. So I'm going back to exercise 2 to see what the mass of the Sun is. And that is 1 and 896 thousandths times 10 to the 30th. Okay, so I have 1 896 thousandths times 10 to the 30th, and I'm dividing it by this number that is the combined mass. 5,986 times 10 to the 24th. How many of these can go in here? So that's why I'm dividing the bigger number by the smaller number. I'm taking my calculator and I'm dividing 1 and 896 by 5 and 986. Okay, and I get this number. I want to take 3 digits after the decimal, so I will take 316, but because my next number to the right is 7, I will round 6 to the 7. So I will have 0 and 317 thousandths. 317 thousandths times 10, and because it's a division problem, I'm going to subtract the exponents. 30 minus 24, and I will get 317 times 10 to the 6th. This number is not written in scientific notation. We need to change this number in scientific notation. Don't worry about 10 to the 6th yet. So my decimal has to be between 3 and 1. And I will multiply it by the power of 10. My job is to find what power that is. Since I'm moving from left to right, to bring it back, I will have to go left. So it will be negative power of 1 times 10 to the 6th. So now it's going to be 3 and 17 hundredths times 10 to the power of negative 1 plus 6, and that is 5. Done. That means that's how many combined Moon, Earth, and Pluto can fit into the mass of the Sun. All right. So now we reach the problem set. Problem set has three problems, and those three problems incorporate multiplication, division, addition, or subtraction. So your job is to find what we are doing and how and why, and I will see you in class.